All right, so let's talk about some basic vocabulary about radicals. Okay, so radicals are anything to do with roots and things. Okay, so a square. Let's talk about a square number first. So a square number is a number that when you multiply it, okay, so it's a number that multiplies by itself. So hopefully you're thinking of some numbers such as 2 times 2 is 4, or 6 times 6 is 36. So these are squares. These are numbers that are squared, okay? So it's when you multiply something by itself. A square root is the opposite of that, right? So it's the inverse or the opposite of a square. So a square root is something like this. So this is a square root. So we're taking the square root of 9. So we're trying to figure out what times itself will give us the number 9. Okay? So more specifically, a word called the radicand, that's the number under the square root. So that's the number under the square root. So the number in that case, or the radicand in this example up here, would be what? Square root. So the radicand in this last example would be 9, right? That's the number under the square root. And then a perfect square is an example just like 9, that when you simplify the square root of that number, it comes out to be an integer. So what's the square root of 9? What times what, or what times itself, will give us 9? Hopefully you know that that's 3. 3 is an integer, so then it's a perfect square. So it's a number whose square root is an integer. Okay, so it's a number whose square root is an integer. So now in your calculator, I want you to start listing all of the perfect squares. So take a moment and do that. Again, so the square root of 4 is 2. We know the square root of 9 is 3. So pause, figure all those out, and then we'll keep on going. So now that you've had those all filled in, let's talk about the key steps to simplifying a square root. The first thing we want to do is to rewrite the radicand. So rewrite this number inside the square root number as a product of a perfect square and another factor. So let's write that down first. So rewrite the radicand as the product of a perfect square and another factor we always want to go with the largest perfect square, okay? So we always want to try to find the largest perfect square because that makes it a little easier to solve down the line. Okay, so eventually I'll show you 2 examples where we find the largest perfect square and see how that works. Always try to find the largest perfect square. So looking at this first example, what would be the largest perfect square? So you have all of your perfect squares up top here. So things that go into 32. I know perfect squares are 4 and 8, but I also know 16 and 2. So perfect squares are 4 and 16. So again, we always want to find the largest perfect square. So now I'm going to separate this radicand into those two different products. So it can be separated into the square root of 16 and the square root of 2. So we separate them into those two different products. Okay, so that's the second step, separate factors. Okay, and our third step is then to just simplify the square roots. Okay, so now we're just going to simplify what we have down here. So the square root of 16 is 4. The square root of 2 can't be simplified to an integer, so it just stays as the square root of 2. Okay, so let's just repeat those steps. So we found factors that go into our radicand, and they were 4 and 8 and 16 and 2. Again, we want to find them based off of perfect squares. Okay, we want to find those based off of perfect squares. Then step 2 was to separate our factors, always going with the largest perfect square. So our largest perfect square we thought of was 16. So we separated our factors into the square root of 16 and the square root of 2, and then we simplified. So we knew that the square root of 16 was 4, and maybe you plugged the square root of 2 into a calculator and you got a decimal. And we don't ever want to put decimals down, so we just leave it as the square root of 2. So then our final answer is 4, the square root of 2. Okay, so let's try the next one. I want you to try to find some perfect squares that go into 343. So I always just start at the basics, start with 4, then 9, then 16, so on and so forth until you find one that works. Okay, so find some factors. So pause and find some factors. I only found one factor, and that was 49 and 7. So again, a perfect square to go into that radicand. So now I separate my factors. So now I branch it off and I plug those factors in. So the square root of 49 times the square root of 7. So that's step 2. And now I simply simplify them. So the square root of 49 becomes 7. 7 isn't a perfect square, so it doesn't get simplified. So it just stays the square root of 7. So now this is our answer. Okay, so I want you to try to tackle example number 3. Once you get to dealing with this 3, I want you to try to figure out what to do with it. But afterwards, I'll have all the steps there and you can try to piece it together. All right, so hopefully most of you got down to this 9 root 5, but that's not the answer. Don't forget, we have that 3 up here. We have this 3 that we have to do something with. So we simply just bring that 3 down and multiply it by whatever number's out front. So now it's really 3 times 9 times root 5. So we just multiply 3 times 9, which gives us 27. And then the root 5 just kind of comes along for the ride. So the only other difference is if we have a number out front, we just bring it on down and we multiply those two numbers out front. Okay, so I'm going to backtrack a little bit And I'm going back to this square root of 32. Okay, so backtracking to the square root of 32. We listed off 2 perfect squares, right? And then I said we always want to go with the largest, simply because that makes our process a little easier. But you may be wondering, what if we don't go with the largest? So let's look at that. What if we go with the square root of 4 and the square root of 8? So now we have 2 root 8. But can't the square root of 8 be simplified? It can be broken down again. There's a perfect square that goes into 8. So that can be simplified again, right, into the square root of 4 and the square root of 2. So I have 2 root 2. You may be thinking, but that's different than before. But don't forget about this 2 here. Just like that 3 has to be brought down, and now we multiply, and it's 4 root 2. So you always have to bring things down for the ride. So this is a little bit more complicated than it was to simply find the largest perfect square and simplify that way. Okay? For this example, I want you to just try to figure out what it's asking, what exactly you should be doing. So I want you to pause and kind of think it over a little bit and try to see if you could take a dive and figure it out. So it's asking for which of these values, when you plug it in for x, simplifies to make this number. So I would plug each of these in to see when I simplify it, if it'll give me this value. So again, pause and try to figure that out now that I've explained it. Okay, so I'm just showing you what I did for A. I plugged in 5 for x, and then I multiplied, and then I tried to find perfect squares that simplify 255, and there weren't any. So it just stays as 2 root 255, which is not equal to that 10 root 51. So A is not an option. Okay, the answer is B, but again, I need to see that work for all the rest of them. So I need to see that you tried B. I need to see that you tried C and D. Okay, so when I check your notes later, that's what I'm looking for. Okay, let's go to the next page. So for this top example, it's pretty much asking the same thing as before, but this time it's giving you what you should start with, what you're plugging in for 2, and what it simplifies down to. Okay, so try to figure it out. I'll let you know it's not A. Okay, so it's not A, clearly. All right, so show me the work for B, C, and D. Pause the video, and I'll let you know what the answer is. Okay, so the answer is C. So make sure you have all your work there. Showing me the answer for C. All right, so let's look at this last part. This is a little different because these have variables in here now. Okay, so remember, we're talking about the square root. So square root and square is 2, right? Something times itself. So let's first by finding perfect squares that fit into 216. Okay, so let's start by doing that. They are 4 and 54. Also 9 and 24. And 36 and 6. Okay, so again, we are always trying to find the largest perfect square. So I'm just ignoring the variables for now. So that's what I would recommend. Ignore the variables. So we're just going with our biggest perfect squares, which is 36 times 6. Simplify that. Square root of 36 is 6. And then a square root of 6. So if we didn't have variables, this would be our answer. But we do. We have k to the 4th. Okay? K to the 4th, remember, is k times k times k times k. Okay, and we want the square root of that. Remember, a square is something times itself. So how many pairs do we have? How many k times k? So we have one k times k, and then we have another k times k. So we have 2 squares of k, which means that since we have 2 even sets of k times k, that the square root of k to the 4th is then k squared. And since we don't have any left over, it goes outside. So our real answer is 6k squared times the square root of 6. Again, that only works because we have 2 even sets of squares. So we have one k times k and a second k times k. If we had any leftovers, they would go inside our square root. Okay, so let's look at something with leftovers. Okay, so let's look at B. I want you to simplify it first, then leave the variables. Okay, so pause, simplify, and then we'll talk about the variables. So I got it down to 16 root 2. But again, that's not accounting for our variables. This time we have 3 m's. So it'd be m times m times m. But remember, we're looking for groups of 2. How many groups of 2 do we have? We have one group of 2. So we have 1 m squared. And then we have that leftover guy. So the square root of m squared is just m. So it would be 16, just 1m, because we only have one pair. And again, we have this leftover guy. We have an extra guy, so he goes back under the square root. So it's 16m square root of 2m. Okay, so try the last one by yourself, pause, and then I'll have the answer up. So if you have any questions for the last one, here's the answer. Please ask, okay? Then the homework's down at the bottom. Make sure you show all your work.